capacitance, we have missed a concept called capacitance. So let me tell you what is capacitance first. So capacitance, so have you ever heard a term called battery? It is just like battery. Capacitance is just like battery. So what is the purpose of capacitance? Means it can store charges in it. So if at all, it is just like a plates, two parallel plates divided with some d distance. If at all I am having a positive charge on one side and negative charges onto the other side, so what happens? Obviously, if it is positive charge, negative charges will be shuffled over here. If it is negative charge, positive charges will be shuffled over here. So if at all I make it as a barrier, it is acting like a battery or not. So one side it is completely positive charges, another side it is completely negative charges. So if I remove this barrier, it acts as a battery. That is what we call it as capacitance. So it can be achieved with the help of parallel plate capacitance itself. If at all I am taking two parallel plates, I want to find what is the capacitance available over here. I can use the formula C is equal to epsilon naught A by D whenever you have free space inside it. Means I am not taking any other material and fixing inside it. Whenever I take free air, this is what the formula you need to use, that is epsilon naught A by D. But if I take any dielectric material inside it, I fix, instead of taking air, I take some dielectric material and I fix it inside. So what happens? This is positive charge, negative charge will be shuffled over here. As this is negative charge, positive charge will be shuffled over here. On the other side, negative charge will be shuffled. On the other side, it will be positive charge. Again, it acts as a battery. So I can remove it and use it anywhere wherever I want for small values. As you can see on fans and all the electric appliances will be having capacitors. The main use or the main advantage of using capacitor is, as you already know, our government will be providing fluctuation of currents. So electric appliances are basically working under some constant voltage. So what happens whenever you use capacitors inside the circuit? Whenever low pitch of voltage comes in, it will give the energy whichever it has stored inside it. Whenever high pitch of current or high pitch of voltage come into picture, it will store inside it. So that is the basic advantage of using capacitor, and most of the circuit boards, all the electronic appliances will have capacitors. And here I have already told you I am placing some dielectric slab that I need to include here in the formula. D by T plus K. K is dielectric constant. Depending on the type of material you are using, K value will differ. As the capacitance is charge available per unit voltage, right? So this is what the basic formula. With the help of this itself, every question is just like new derivation. Here we can't use any shortcuts or any technical terms because every question is different from the previous one. So let us see some basic concepts where you can interlink. So not only capacitance, I am also including the concept of resistance so that you can interlink here as well as in the further chapters. So if at all normal resistance is equal to, if at all you have connected in series, current is passing inside the circuit, series resistance or equivalent resistance is equal to R1 plus R2, that is series R series. If you are connecting them in parallel, that is 1 by R1 plus 1 by R equivalent is equal to 1 by R1 plus 1 by R2. That will be reciprocal of the given series circuit. But when you come back to the capacitance circuit, that is quite reverse to resistance circuit. See, whenever you are connecting them in series condition, as you can see R1 plus R2, that will be reciprocal. Similarly, whenever you are connecting in parallel condition, that is C1 plus C2, whereas in resistance condition it is reciprocal condition. So here it is 1 by C equivalent. So this is how we will proceed further with the help of basic formulas, and we will make it an derivative form. Using small formulas we can derive it and we can use it in the real time scenarios and applications. Right? I hope you guys understood it. Let us solve problems.